So question 32, all about functions and transformations. Let's see how you go on with this one. Okay, so here in the top right hand corner is a picture of our function f of x in green, and we're now going to consider the function f of x plus 2. So what we're doing to get x plus 2 is we're putting x plus 2 where the x is. So g of x is x plus 2 all squared. So that's confirmation there. G of x is x plus 2 squared. And this is a translation by the vector -2, 0. We're translating it 2 units to the left. When we're inside the brackets, as we are here, we're affecting the x values, and it's the opposite of what you might expect. So another way of thinking about this is to say that, well, when does x plus 2 squared equal 0? And that's when x plus 2 equals 0, which is when x equals -2. So that's another way of thinking about what the effect of that translation is. So here's a little graph of what that looks like. So the little graph here isn't required by the question, but I thought I'd pop it in there just to show you, if you need to look at it, that the graph of f of x has been translated 2 units to the left to give us the red graph. So what about h of x? H of x is 3 times f of x plus 2. Well, f of x is x squared, so this is 3 times x squared plus 2. So that's h of x there, 3 times x squared plus 2, which is a stretch by a scale factor 3 parallel to the y-axis, followed by a translation by the vector 0, 2. This is because we've got 2 transformations here. We've got the multiplying by 3, and then we've got the adding 2. So we have to decide which one to do first. It makes a difference whether we do the multiplying by 3 and then the adding 2, or the adding 2 and then multiplying by 3. And here, because both of the values are affecting the y values, we are going to be using BODMAS. So BODMAS tells us that we do multiplication and division first and then the translation. So this is what the eventual graph looks like. Again, this little graph is not required to be part of the answer for the question, but it's just there for your information, really. The blue curve you can see here is stretched and then translated by 2 units in the y direction. So what about the final function here, f of 4 minus 4, f of x minus 2? So what we're doing is we're putting the x minus 2 where the x was, but then we're multiplying by -4. So it's -4 x minus 2 squared. So here's confirmation of that. So this is what the function v of x looks like, and we are doing 3 transformations here. The first pair of transformations are to do with the multiplying by -4, and then the second one is the third one rather is the transformation where we've got -2 inside the brackets. Well, these transformations here are affecting the y values. These are affecting the x values. So the y values are being multiplied by 4, so it's a stretch by a scale factor 4 parallel to the y-axis, but they're also being multiplied by -1. So that's why we get a reflection in the x-axis. Then the -2 inside the brackets translates the function by 2 units to the right in the positive x direction. And it doesn't matter which order these transformations are done in, because they're independent. One pair of transformations, the -4 effectively is affecting the y values, and then the -2 is affecting the x values. So it doesn't matter which order we do those transformations in. Whereas with the previous one, both of the transformations multiplying by 3 and +2 are both affecting the y values, so the order did matter there. So there is a confirmation of what the curve looks like, the transformed curve in relation to the original curve of f of x. Hopefully you got the same answers. Hopefully you did. If you did, well done. And we'll move on to the next question.